Okay, so this is identical to the one you'll see 2 weeks from tonight.
Same numbers?
Yeah, same numbers.
Oh.
Write them down. Write them down.
Where's the wing? You're supposed to give me a wing too.
I was winking at the rest of the class, not you. Try to get in the habit of writing down the symbols because I do too. If I'm not, I'm constantly reminded of what value I'm working with. I make mistakes. Yeah, I've done a redraw.
$400.022 for resistance.
How about just for the bottom half?
Oh.
For the bottom half was 12.94.
Okay, 12.94, because I expect it to be below 45.
Right.
And then I've got 400 above, which gives me 4 to 12.94 resistance total.
We're getting okay. We're getting a different number from you, and that's what goes on to it.
Yeah.
Alright, let me see.
So you got,
For your total resistance.
so the bottom half, you got how much?
31.
31. So you got 431 resistance total. So now you want to figure your current, total current.
It's 0.11. Or 1.2.
0.12 amps for 3.
Yeah, 31.
So I got a total current of 0.12 amps, and where else can I plug that in?
5, 6, and 1.
R1, R2.
R1 and R2 only.
Oh.
The reason it's only one R1 and R2 because this is aisle number 4 at the grocery store. I don't know how to describe it. And here we are. There's only a single path. So the current's going to be the same for R1 and R2. And then it's going to split 3 ways. So if you look at my redraw, what I would be doing next is working on your currents. Okay, so, well, what you need is a voltage drop first for the top half. You got 50 volts, and the 2 top resistors combined, you can either do them individually. You can do them individually. What's 50 divided by 150? 125. 18? No, it's not that much.
What did you ask?
It's 14.5.
I got 15 volts for the drop.
Okay, well, I'm looking at, it's volts divided by resistance, so it's 50 divided by
I
125.
did I times R.
Yeah, because we don't have the volts yet, so.
The
Now we're
total
trying to get
votes
the
Oh,
volts.
no, you're right. Current, it's the current that we're after.
Current times
So
resistance.
we're after voltage.
Yeah.
Yes, but you have the total current for up here.
Yeah, right.
Yeah.
So current times resistance.
Will give us 14.5.
Yes. 15 volts.
14.5 volts for R1,
Yes.
Yeah.
The total is 46.4.
and then, so R2 is how much?
31.9.
31.9,
Yeah.
and the total is,
46.4.
So 46.4 away at the top, those two resistors. So we're losing most of it. So down at the bottom, that gives us 3.6.
Yep.
So we got 3.6 down at the bottom. So R3 and R4 are by themselves. So they're gonna see that whole drop, right? So my voltage drop for 3 and 4 are gonna be 3.6 each. These are 14.5, 1.9. We're given. Yes,
I think the voltage in R2 is 33.
it's 33.
Pretty much.
Oh, because the resistance right there is 255 and it's 270.
Because your resistance is 0.116. Your current.
Round it up.
If your current is 0.116, not 0.12, so you put 0.12.
Everything
you give you a
rounded
higher
up.
number.
Okay, I'm gonna go with 0.116 because it,
It's more accurate.
yeah. Usually I do my rounding when I put the final answer in the lines off to the side. That's usually when I do my last rounding. Okay, so are my voltages good? This is 33. R2's voltages drop is 33.
Not anymore, it's 31.9. How'd you get 2.6 for R3 and 4 for voltage?
Okay, for R3 and 4, we got a voltage drop up here of 46.4
Right, total of those.
of these two in series. They're gonna split that. I mean, well, they did. If you notice, one's 14.5 and one's 31.9. So combined, they're 46.4, and it's a 50 volt power supply. So we get that drop. This parallel section sees 3.6 volts. Since
R3 and R4 are the same.
since they are all by themselves, they see the full drop. These two are in series,
5 and 6 are gonna see it too.
but combined.
Because it's, I got that different currents.
So which I would keep. See, that's why I wrote 5 and 6 as kept them together here until I get the current. Because now I'm going to get all three currents the same way. I'm going to use the resistance with the voltage. So what's my current for R3?
Point for R3. 0.018. We don't.
0.018?
Current 0.18.
And then R4?
0.08.
Okay, so now I'm going to use the combined resistors at 200 ohms with my 3.6 volts. Point.
No. Exactly.
Okay,
It'll be the same as R3.
you're correct.
Yeah, I got
Yeah,
0.118.
0.018. So now I have the currents for this path. So both R5 and 6 are going to see 0.018 because they're in series to each other. So .018.
The voltage would be 108.
So now I have a current and I use the individual resistance. So what's my voltage for 5 and 6?
1.17.
And 6?
2.43.
2.43.
How'd you get the current for 5 and 6 again?
Okay, for the current for 5 and 6, I kept them combined.
Right.
So I got the currents for this leg, 5 and 6, the same way I got these two. I used this 3.6, you know how we got the 3.6 volts?
That's what was remaining from the.
So this is our 3.6 volts at 200 ohms gave us 0.018 amps. The next one is 45 ohms at the same voltage. And this last leg was the same.
Gotcha.
We could still do the math, but we're gonna get the same number. And they're series to each other, so they,
Right, and then it gets split, I see.
then we split them. And if you do the math, this 1.17 plus 2.43 should add up to our 3.6 volts. Now, if you remember, we still have two resistors up here, so we did their individual voltages. Yeah, we're done with those. Yeah, they were 14.5 and 31.9. So the two resistors on top doesn't make much difference, right?
Yeah, but you rounded over here, that 31.9 is really 29.6, so the residual down below,
No, that's 31.9.
if you take 0.116 times 275, what do you get? 31.9. My calculator is.
It's on the Fritz.
It's the calculator's fault.
Never mind.
You're on the fix.
That damn calculator.
I erased this 3 times. It's overheating.
Okay, so
Alright, I'm gonna let that go.
7:30. So we're here till, at least in this class, till 7:50. You got 20 minutes.
You said review for test?
Oh yeah. Excellent.